Hi, my name is Vijay Chandu. I'm from CSC AML branch, and I'm going to explain about kurtosis and types of kurtosis and measure of kurtosis. Overview of presentation. First of all, introduction of kurtosis and types and calculation of kurtosis, an example of kurtosis, conclusion and references. Introduction of kurtosis. The word kurtosis comes from the Greek word kurtos, meaning humbled. Kurtosis gives an idea about the shape of frequency distribution. Kurtosis is the measure of peak of distribution and indicates how high the distribution is around the mean. Kurtosis indicates whether a frequency distribution is a flat, normal, or peaked shape. Here are the types of kurtosis. First one is leptokurtic, second is platykurtic, third one is mesokurtic. Here is this red line is leptokurtic, which is high peaked. Mesokurtic distribution is normal peaked, and next platykurtic is flat in shape. So first of all, what is leptokurtic? It is a curve having a higher peak than normal curve, too much concentration of the items near the center. It means here. Next, platykurtic, a curve having a lower peak, flatter than the normal curve. Here, mesokurtic we consider as a normal curve, so it is lower than normal curve. There is less concentration of items near the center. It means here, mesokurtic, it is a curve having a normal peak or normal curve. There is equal distribution around the center value. It means at the mean point. In such case, mean, median, and mode are equal. Calculation of kurtosis. To calculate the kurtosis, the following methods are applied. The first one is percentile measure of kurtosis. The measure of kurtosis based on the quartiles and percentiles is known as percentile kurtosis. To calculate the coefficient of kurtosis through this method, the following formula is applied. So we mostly use measure of kurtosis based on moments. So here is the written interpretation. If k is equal to 0.26, the distribution is mesokurtic or normal. If k is greater than the value, the distribution is lepto. If the k is less than the distribution, it is platykurtic. So coming to measure of kurtosis based on moment, Carl Pearson suggested the following coefficient of kurtosis based on the moments. The coefficient is also known as the moment coefficient of kurtosis. To calculate the coefficient of kurtosis through this method, the following formulas are used. So beta 2 is equal to mu4 by mu2 square. This is the formula we use to calculate, where beta 2 is the moment coefficient of kurtosis and mu4 is equal to fourth moment about the mean and mu2 is the second movement about the mean. The simple formula is given here. Next, here is the little interpretation about measure of kurtosis using movements. If beta is equal to 3, then the distribution is normal and called mesokurtic. If beta 2 value is greater than 3, then the distribution is leptokurtic or more peaked. If beta 2 is less than 3, then the distribution is platykurtic. It means flatter. Here, in this k is greater than 3, so the distribution curve is leptokurtic. So here k is greater than leptokurtic or positive kurtosis. Conclusion. Kurtosis indicates whether a frequency distribution is flat, normal, or peaked. Kurtosis is a measure of peakness of a distribution. The larger value of the peakness of distribution, the kurtosis is calculated and reported either as an absolute or relative value. An absolute kurtosis is always a positive number. It means leptokurtic. Absolute kurtosis of a normal distribution is 3. And this is how I present kurtosis. And thank you.